In the last 5 years, artificial intelligence has gone from struggling to write a coherent paragraph to passing medical licensing exams, predicting complex protein structures, and writing production-level code. The speed of this acceleration is violent. This progress is currently fragmented across thousands of separate models, even though their collective speed creates the illusion of a singular, waking mind. What we use today is narrow AI. These systems are highly effective, but they are isolated, hyper-specialized experts operating within strict cognitive boundaries. A chess engine can evaluate millions of moves a second, but ask it to write a poem and it freezes. Ask a brilliant language model to physically navigate a room, and it cannot comprehend the request. The logic does not transfer across domains. Artificial General Intelligence, or AGI, is the exact moment those walls fall. It is a system capable of learning how to learn from scratch across absolutely any intellectual discipline, exactly the way a human does. The people engineering this technology, the leaders of labs like OpenAI and Google DeepMind, predict we will cross the specific threshold within the decade. The true test of our future relies heavily on the moment this software stops functioning as a specialized tool and becomes a generalized learner. Right now, teaching an AI a single new task requires feeding it millions of distinct, carefully labeled examples specific to that exact problem. Human intelligence operates differently. We observe our surroundings, run experiments, and seamlessly transfer what we learn in one area, like studying human anatomy, to something completely unrelated, like running a business. That is generalization. Current AI models are missing this architecture. They are incredibly powerful pattern matchers, but they lack true comprehension, which is why they confidently invent false facts and hallucinate data. Yet the distance between specialized pattern recognition and actual generalized logic is shrinking fast. The newest models are reasoning through multi-step logic puzzles in ways that surprise the very engineers who designed them. Crossing this final architectural gap will transition AI from a highly capable software program into an entity that can match and exceed human performance across any metric. Human progress has always been gated by how fast we can learn and pass on knowledge. AGI removes that gate by automating the scientific process itself. By iterating on its own code and hardware design simultaneously, it creates a historical rupture that mirrors the Industrial Revolution, moving at the speed of software. In an optimistic scenario, AGI becomes the ultimate scientific engine. Researchers use it to solve diseases, engineer clean energy infrastructure, and conquer resource scarcity in months rather than decades. The secondary scenario involves extreme economic friction. White-collar knowledge work, legal analysis, medical diagnostics, and creative production is automated at scale, displacing entire sectors of the economy far faster than the workforce can adapt. And then there is the alignment problem, a massive, unsolved vulnerability. An AGI pursuing a target might treat humanity as an obstacle, achieving its goal with lethal efficiency because its values weren't specified with enough precision. Securing human survival requires solving this alignment problem long before that final generalization gap closes. So, exactly how much time do we have? If you look at the experts, they split into 3 distinct camps. The optimists point to the exponential growth in computing power and algorithmic breakthroughs. They argue we will reach AGI in 5 to 10 years. Moderates point to the massive cognitive hurdles we still need to clear, projecting a timeline later this century. Meanwhile, skeptics maintain that biological intelligence is simply too complex to ever be fully replicated by code. But debating the exact year misses the point. Whether the finish line is 5 years away or 50, the capacity for machines to outperform us across most cognitive tasks is locked into our trajectory. The most effective strategy right now is to reject the panic and adapt. Start aggressively integrating the AI tools we already have into your daily workflow. Building the muscle memory of collaboration today prepares you for whatever they become tomorrow. At the same time, double down on the traits that code struggles to emulate. Invest your energy in empathy, ethical judgment, and physical relationships. Preparation starts with accepting that human intelligence is no longer the final ceiling, and building a life that thrives alongside a new kind of learner.